Okay, more computer play. Although I'm gonna be looking at I'm gonna look in a radio a little later. Um, as soon as I find my SD cards, and I mean, we've got an army of them, but I've got some that I use for the camera, and I've got to clean them up. So, nevertheless, we're looking at again Mike's picture of his radio. Okay. Um, I've got one of another radio that I just got because I figured, you know what, I better have a second one that's not modified in any way because I'm going to let the blue smoke out of something, one of these transistors, and I'm going to have to be able to identify it. So it's best that I have another one. So I've got another one. Um, so where is that picture? Here it is. All right. So I'm discovering some little tidbits about this. So this is a shot of the radio, and see the MCU is covered by this metal bracket. Got to go and pull the other cover. I'll pull this thing out and get that faceplate all apart, get the board out of it. It's a pain in the neck. But we've got a receiver over here, an FM receiver, VHF. What I'm starting to think uh, some support is there for is an FM mode on the radio. And that's just because there's some peculiar things going on with it, and I'm not 100% on that, but there's some interesting things. So you know, eh, I'm still trying to map out some of the bits of it, particularly in the VCO and in the PLL, and of course, if you're gonna have an FM mode, you're gonna have some things in the VCO, you know, that are interesting, and there's some things that are interesting about it, which makes me think, we've already got a discriminator here, so we got a receiver. Makes me wonder if they didn't have any other intentions for this radio, um, because it appears to me that they're using this PLL for the VHF as well. It's certainly capable of doing it. So that's interesting to me because first of all, this radio will never transmit on on VHF. So, it obviously can't do that, but it certainly can possibly transmit on FM uh, on HF. So, yeah, I'm starting to wonder if that wasn't something that they may have tried to tweak into it a little bit and then they decided not to, or maybe they got caught with their hand in the cookie jar by the FCC on that. And the FCC made them reel that back in because there's some interesting stuff in there. Some leftover bits, I suspect, that would make this capable of transmitting on FM. But that's a completely other discovery altogether. So I'm just going to leave well enough alone for the time being and not fool with it. But the interesting thing about this is, since I am mucking around with this PLL and it's being used for the VHF, this radio potentially has the capability of being a scanner uh, for VHF. It's got the capability. If I have to replace this microcontroller, I'm certainly going to do in software capability of doing exactly that. It would be stupid for me not to. You have it, why not use it? Because I'm gonna essentially, if I make it work, it's gonna be able to go to whatever frequency, a set of frequencies I want it to go to. As far as maybe more general coverage receiver. I don't know what the receiver, uh, what how wide this thing is. I'll certainly find out, but um, the capability exists for more general coverage on the receiver. Um, it might be cool if it had a scanning mode that said, um, monitor 2 meters or something like that, some repeater on 2 meters, and then you'll certainly not be able to talk there. But if somebody opens that repeater and it's monitoring it, like it just ticks it to see if there's a carrier there, and then it certainly would be interesting to do, um, just because, you know. Now, regarding replacing the MCU, I've got a lot of mixed uh, responses about a castellated board. Now, what I mean by a castellated board is this was me goofing off here. Okay, see, I've got these. These are just pins. Okay, but you see, I've got this one here. Now, what this looks like in the 3D view is this. You have to keep in mind that when they make the board, try to zoom into this thing, and they cut the board, they're going to cut right through that. So the board house will cut right through that, and you'll have this half circle area for soldering. So you would solder the board. I mean, most people who watch these things, they know what a castellated board is anyway. I mean, you guys mostly, for the most part, know what I'm talking about here. But I'm trying to figure out if I can get one of these that's the size of the existing microcontroller that is uh, somewhere. Let's see if I can get this thing to start going through the photos. There we go. Like Mike's here, 0.8 pin pitch. Can I get it that small so that basically you lift this guy up, you put this board down in its place like you would any other chip. You flow the pins around the the castellations, you flow them in place, and then on top of that, we have a high density board-to-board connector so that we could slap another board on top of it that has our stuff. But there is one thing that I just failed to consider when I was fiddling around with this, and that's that metal plate that goes over the top of this. Um, there's absolutely no clearance there. Um, so I'm kind of at a loss as to how I'm going to make that work with that metal plate there. Um, it's probably going to take some modding of that metal plate. Um, and I don't have a good shot of it in my pictures. I mean, I've got a, you know, maybe this metal plate could be cut from here to here, um, to open that area up, and you would still have the metal bit that goes from here and to here, and that goes up and around, to this. Um, but I have a feeling that if I get it to work, this metal plate's going to get tin snipped. And what I mean by tin snipped is, I mean literally, you're just gonna have to pull it apart, grab a tin snip, and go cut and cut it, and cut that little square out, and move on. So the jury's still out as to whether or not this is really an effective trick. So my thought is, and I can't recall what. Oh, I put this so we do the same to this one, just for illustration. No, come on. And we're just going to put this to like 0.4, and so it's like this, and then we just have like another track uh, that would come off of this and just go wherever. It didn't come off really straight, but that's okay. We can make it more straight. So let me just move this first. So we're going to move this thing, and let's say there. I think it's about right. Um, and see what that looks like. You see those guys are pretty close together. So, it's just a matter of now, uh, having a track that goes off of this and then goes to wherever your connector is. Um, and you move on with life pretty much. So, not sure why. Okay, so we got a track there. This one has a 1, this one doesn't. I must have screwed it up somehow. Um, but so that's basically it. Um, this yellow line is the edge cut. So this is where they would saw the boards apart, and of course right through the pads. So just for the sake of argument, if I like measured this thing, I don't know, like think that's roughly the middle. That's almost right. They need to be a little bit closer, but that's almost right. So that will certainly work. But whether or not I can, you know, I mean, there's no doubt I can stuff 80 of these things in a square, and then have them all go to a connector, uh, and then a second board plugs into that connector that has the replacement microcontroller, and whatever support that replacement microcontroller requires, which will probably be just a oscillator and doubtful of voltage regulator. Um, Although I don't think this 3.0, no, I need a voltage regulator, but I need a small one because I'm not going to consume a lot of power. So that's the thought. Uh, any questions, comments, suggestions? Am I just crazy about this whole castellated square PC board adapter idea to essentially replace a quad flat pack? Let me know.